Good morning. Welcome to GATE lecture video series. Myself Ms.S.KRISHNAVENI, Assistant Professor, Department of Information Technology. Today I am going to take Transport Layer Protocol, TCP and TCP header topics. So, computer networks is an important topic under computer science society. For if you are going to GATE examination, so you have to well knowledge under computer network subjects. So we are going to discuss about characteristics of TCP and TCP header, then GATE questions and answers on TCP and TCP header. Introduction about Transmission Control Protocol. TCP is short for Transmission Control Protocol. It is a transport layer protocol. So why we are going for TCP means to send data packets over the internet. So over internet, how we can send the data using the protocols. For transport layer protocol, we are using the TCP protocol for data transmission. So first, it can establish a reliable end-to-end connection before sending any data. So the next we are going to discuss about the characteristics of TCP. So first point, TCP is a reliable protocol. So as already we are told, this is TCP is for reliable connection established between sender and receiver. How we can achieve this reliable mean? It guarantees the delivery of data package to the correct destination. So after receiving the data packet, receiver can acknowledge this is I am receiving the correct sending data. If any data packets is missing means TCP can establish a retransmission of the correct data from sender to receiver. Okay. So the next point, TCP is a connection-oriented protocol. Why is called as connection-oriented protocol means TCP establishes an end-to-end connection between the sender and the destination. So the connection is established before exchanging the data. First step for TCP is connection establishment. Second, it is start to transmit the data from sender to receiver. The connection is maintained until all the application programs should be transmitted from source to destination. So third point, TCP handles both congestion and flow control. Flow control means the data packet size. This is based on the window size of sender and receiver. So there is a flow control as well as congestion control. Congestion control means some of the traffics, network traffics, everything should be handled by the TCP. Then fourth point, TCP ensure in-order delivery of the data packets. So this is because TCP ensure that the packet get delivered to the destination in the same order they are sent by the sender. So the sender can send the data packets starting from sequence number to some bytes of data. The correct order should be received by the receiver. This is the in-order delivery. Whatever format the sender should send to the receiver gets the same format. This is called as the in-order delivery of the data. For that purpose, we are using one field. This is called sequence number. Sequence number are used to coordinate which data has been transmitted and received. So next point 5, the TCP connections are full duplex. So full duplex means at the same time the sender and receiver can transmit the data at the same time. So TCP connection allows to send data in both the direction at the same time. So what it is called as the full duplex. So point 7, TCP is a byte string protocol. Why is called as byte string protocols means from application layer to transport layer, more number of data, unlimited data transmissions carried from application layer to transport layer. This is a continuous process. So what transmission layer should do means it can divide all the data into data chunk. This is stream of characters. This is called fragmentation. This should be combined in one data TCP segment. TCP segments means it is a combination of TCP header as well as data chunk. So this is the bytes of data. Okay, so it is called as the byte stream protocol. This is all we are discussed. The next topic we are moving to the TCP header. We are going to discuss one by one. Totally it is 32-bit header. So it's first one is source port, second destination port, each 16-bit data, then sequence number, this is 32-bit, again acknowledgement number, then header length is only 4 bits, reserved bits it's 6 bits, remaining all flag bit, then window size, this is 16-bit, checksum and urgent pointers, then last two options 0 to 40 bytes, data optional one. This is the format, overall format for TCP header. Now we are going to discuss one by one. First, source port, it is 16-bit port, okay, 16-bit segment. Why you are using source port means it identifies the port of the sending application. It starts from sender to receiver, maybe client and server communication means start from client. So sending application port should be identified using source port. Second, destination port, it is again 16-bit segment. It identifies the port of receiving application. Third, sequence number, it is 32-bit field. TCP assigns a unique sequence number to each byte of data contained in the TCP segment. So TCP segments start from sequence number. For this sequence number only the receiver can identify which data can receive from sender. For this purpose we are using sequence number. It's at 32-bit field. This field contains the sequence number of the first data byte of the data segment, TCP segment. Then acknowledgement number. So this is also 32-bit field. Why we are using this acknowledgement number means the receiver, whether the receiver can receive all the data from sender is in correct format, then he can get the acknowledgement number. So acknowledgement number, how we can find out means this value is sequence number should be incremented by 1. Sequence number plus 1 is called as the acknowledgement number. Then as per our diagram, next topic, header length, it is a 4-bit length. So header length is a 4-bit data offset field, also known as the header length. It indicates the length of the TCP header so that we know where the actual data can begin. So, okay, that's the purpose header length is used. Again, next one is reserved field. It is an optional one. It is always set to 0. It is only 3-bit field. Remaining all is called, the remaining 9 bits is called as flat bits. Okay. So as per diagram, you can see header length is 4 bits. Remaining reserved bits, it should be divided into 2. This is 3 bits is reserved. Remaining all this 9 bits are called as flag bits. It is also called as the control bits. Why is called control bits means from here only the connection establishment and all important controls parts is beginning. So it's called as the control bits. There are 9 bits for flag. We are called them control bits. We use them to establish connections, send the data and terminate the connections. Flag. URG, ACK, PSH, RST, SYN, FIN. This is all flag bits. URG means urgent pointer. You have given most important priority over than other data when this bit is set to 1. Okay. So again next ACK means acknowledgement. ACK is only for the purpose of acknowledgement. ACK is equal to 1 means the receiver can send the reply to the sender. PSK means push. Push function means tells an application that this data should be transmitted immediately. Then reset RST, reset a connection. Once RST is equal to 1 means you can reset the connection. When you receive this, you have to terminate the connection right away. This is only used when there is unrecoverable error and it is not a normal way to finish the TCP connection. SYN, it is equal to 1. We use this for the initial three-way handshake and it is used to set the initial sequence number. When the connection is started to establishment, the data, this is TCP segment is ready to transmit from sender to receiver. So the sequence number set by SYN flag. Last one, FIN, is a finish. When this flag is set to 1 means the connection should going to terminate or release, or close means FIN is equal to 1. When we are going to close, if any unrecoverable connection error or no other data is ready to send from sender to receiver, that's the situation we have to set FIN is equal to 1. So this is a overall flag registers in TCP header. Totally 9 bits field. Next 16-bit field is window. So window field specifies how many bytes the receiver is willing to receive. When the sender and receiver is ready for communication, so window size should be set. Both the sender and receiver window size must be equal. Then only the correct format of data should be transmitted from sender to receiver. That purpose window size should be set. So next is checksum. Checksum is a 16-bit are used to checksum whether the TCP connection integrity is good or not. So connection integrity checking based on this checksum. Next, urgent pointer. These 16 bits are used. The urgent bit, URG bit, this is the flag bit we already discussed. This is URG. Priority over. When URG is equal to 1 means that bit is urgent, most urgent. This is the priority. So URG bit has been set means the urgent pointer is used to indicate where the urgent data ends, or finding out urgent pointer we are using this. Then optional, it is an optional one, can be anywhere between 0 to 320 bits. Hope you understand. So now we go for one example for TCP header. This is the hexadecimal format of TCP header. From here we are going to understand each and every field of TCP header. So first, this hexadecimal value should divided based on our TCP header field. So this is the diagram for TCP header. First field, source port number, it is the 16-bit field. Okay, so 16-bit field means first 4-bit indicates the source port number. So each occupies 4-bit. Okay, 4, then 16-bit, it is a source port number. Second 16-bit occupies destination port number. So first one, source port number 16-bit, destination port number again 16-bit. Then next 32 bits of sequence number. So 32 bits means 4 plus 4, 8. This is 16-bit. This is called a sequence number. Then acknowledgement number is also 32-bit. So each occupies 4. 4 plus 4 plus 4 plus 4, 4, 4, 4, 4. So it is 32-bit acknowledgement number. Again we are going for the fourth row. This is header length. It occupies only 4-bit. 4-bit means only 1. This is 9. This 9 indicates header length. Okay. Next, reserve bit and flag, it occupies remaining all fields. 4 plus 4, 8, then 12 plus 16. This 16 bits is called as the reserve flag bits. Again next we are moving for window size. This is 16 bit. This D630 is checksum field. Then 0014 is called urgent pointer. So based on this TCP header format, we are divide the given hexadecimal value for the each and every field. First step. Then second step, convert all this hexadecimal value into decimal value. Okay. So first source port is 16-bit. Hexadecimal value D444. So decimal value is 54340. So from this decimal value we can identify the port number, which this port number comes which type. 0 to 1023 means it's a well-known port number. 1024 to 49,151 means it is a registered port number. Again 4952 to 65,535 means it is ephemeral port number. So we are going to find out the port number from this first part. So now we have a value of 54,340. It comes under ephemeral port number. It is nothing but a temporary port number that should be assigned by purely client process. Okay. So ephemeral is a temporary port number. It is only assigned for the client. If it is comes in between 0 to 1023 means it is a well-known port number. This well-known port number is only assigned for the server. So source number 54340 is comes under client. So our communication start from source port, this is client. Destination port number 0017, corresponding decimal number 23. So 23 means it is comes under well-known port number 23. So it is purely assigned to the server. This is telling this is server. So client to server. Our source is client, destination is server. So connection establishment start from source to destination. Then a third field is sequence number. It's a 32-bit. So corresponding decimal value 4356. Sequence number means the data segments first data field, right? So first byte number carried in the TCP segment. The next field acknowledgement number, corresponding decimal value 30. What is meaning for this means first 29 bytes has been successfully received by the TCP. Next expecting bytes are from byte number 30. Okay, this is for acknowledgement number. 30 means I already received 25 bytes successfully. Now I am waiting for the 30th byte. Then header length 9. So hexadecimal value 9 as well as decimal value 9. Here is an important part. Hexadecimal value 9. So we have to find out exact header length. So header length field is 9 into 4. 9 into 4 is equal to 36 bytes. So original header length is 36 byte. This formula already I discussed in previous slides. This is header length field is equal to header length into this value. Here 9 into 4, 36 bytes is our original header length value. Then reserved byte flag. Here we have to no need for decimal value, only binary value. 0, 3 zeros, binary value is 1, 1, 0, 0, 0, 0, 1. We have 6 flag registers: urgent, acknowledgement, push, reset, synchronization and finish. So here urgent and acknowledgement segments only set to 1. So we are having only 2 flags equal to 1. Then window size, there should be 1023 window size. Up to 1023 data we can transfer from sender to receiver. Then checksum field D630, decimal value 54832. So our checksum field is both the sender and receiver is equal to 54832 decimal value. Last one is urgent pointer 0014, corresponding decimal value 20. So urgent pointer is for calculations of up to how much data I want to transfer. So 20 bytes. So already we have sequence number. This is 4356. So 4356 plus 20, 4376. Up to this data we can send. if URG flag is equal to 1 means we can send the data from 4356 sequence number, starting sequence number plus origin pointer value 20. So totally 4376 data should be transferred, but it is not in a sequence order. So hope you understand this one. Based on this is the very basic. If it is having well knowledge about this, we can go all related TCP gate questions easily. So our answers, what is the source port number? So 54340, this is our source port number, destination port number 23, sequence number 4356, acknowledgement number 30. So header length is different, header length field. 9 is header length field, but our header length value is 36 byte. Okay. So reserve byte, which segments are alive, which flag register is set to 1 means urgent flag and acknowledgement flag is set to 1. So window size 1023 bytes, checksum value, everything should be answered based on our this calculation. So now we move for the basic TCP and TCP header gate questions. First one, consider the following statements. First statement, TCP connections are full duplex. TCP has no option for selective acknowledgement. TCP connections are message streams. So these three options based on TCP characteristics. So which one is correct? Option A, only one is correct. B, C and D. In this question, all can very well known. TCP connections are full duplex. Okay. So option A is the right answer. So TCP connections are full duplex means so client and server. If you are going to create a connection means it is a full duplex. At the same time, client can send the data to the server as well as server can send the data to the client. So it is called as the full duplex. So option A is our right answer. So we are moving to the next question. In which of the following terms the sending and receiving data is done in TCP? So TCP, the communications in which terms? We have 4 terms. Stream of bytes, sequence of characters, lines of data and last packets. So as already we discussed, from application layer to transport layer, unlimited number of data should be transmitted. So what transport layer should done means it should receive all the data in terms of streams of bytes. TCP means streams of bytes, UDP means in the terms of packets. Okay, so here the right answer is streams of byte, option A. Next question, what is the size of source port in a TCP header? So source port, it is the first field. As a diagram we already discussed. It is start from source port only. Here a diagram, TCP header 0 to 16 bits. Then again this first 16 bit is source port, last 16 bit is destination port. So what is the size of source port? The answer is 16 bits, not byte, 16 bits. Option 16 bytes, 32 bytes. Option C 16 bits. Option D 32 bits. Very careful, bits and bytes totally different. So option C 16 bits is the right answer for this question. We all know the answer, but when we see 16 bits, we never give concentration of bits or bytes. So sometimes we may make mistake during this answering this question. So give little concentration for answering this type of question. So correct answer is 16 bits. So now the question, how many packets TCP need to complete the exchange of information between sender and receiver? So sender and receiver, how many packets we have to establish? For this, first client and server, first step, connection establishment. There should be start connection establishment. It can send first connection SYN synchronization field, then from sender to client, this is SON plus acknowledgement. Again from sender to client, this acknowledgement should be fast. So 1, 2 and 3. So how many packets means? Option B, this is 3 is the right answer for this question. Okay. When we are going for connection establishment, from client to server, the data should be transmitted. Then server to client, it can send original data plus acknowledgement number. Then this acknowledgement should be the 3-way of communication. Answer is 3. Then 10th question, the first few hexadecimal digits of TCP header are given. This is the first few hexadecimal value. Which of the following is or true? So we can understand from this question which of the following is or true means for this question we have 1 or 2 more answers. Okay. So first we can discuss the question. Here some of the hexadecimal digits value for the TCP header. So immediately in your mind you have a diagram of the TCP header. First is source port, destination port, then sequence number, acknowledgement number, header length and flag fields. Okay. So first 4 bits. This is 5EFA. Okay. So this is called as source port. Okay, source port is the 16 bit, right? So 5EFA 4444. This 16 bit is called as the source port. Again, next 16 bit is called the destination port. So 16, first row completed, second row sequence number, it occupies 0 to 32 bit. Okay, so 32 bit means this all combined is called sequence number. Okay, so this is source port, this is destination port and followed is sequence number based on our TCP header diagram. Okay, so we are going to answer the following parts. Which of the following is are true? Here we are going to find out source port, destination port. So 5EFA is a hexadecimal value that should be converted into decimal value. Here 5EFA. So it is in the 16 field. So it should be converted in decimal means 5 into 16, 0, 1, 2, 3. 3 plus E into 16 2 plus F into 16 power 1 plus A into 16 power 0. This value is 24314. You have to calculate this. So our source port decimal value is 24,314. Okay. Then we have to calculate the destination port decimal value 00FD. It is in hexadecimal value. So 00 left, then F into 16. So 0, 1, 2, 3, 16 power 1 plus D into 16 power 0. The value is 253. Okay. So first option is one correct answer. Source port is 2431 and destination port decimal value is 253. But from our question, which is the following is are true. So again we are going for the another one right option. So this one is 24314. This one is 253. This is destination port value 253. So already from diagram we can understand well-known port start from 0 to 1023 is called as well-known port number. Well-known port number means telnet that should be assigned only by the server. Okay, so 253 comes under well-known port number. So this destination port is server. Okay, so source port is automatically client. From this we can understand packet is going from source port, this is client, to destination port server. So the second right answer is option C. Again I am going to discuss little bit. From this hexadecimal value we can understand what are the field of TCP header. First 4 source port, second 4 destination port, remaining 16, this is 32-bit sequence number. Okay, so first what we are going to do, this hexadecimal value should be converted into decimal value. So we can get the source port value 24314, destination port 253. We already know 253 is a well-known port number. This is well-known port number means this should be assigned purely for the server. So destination is server means source port is client. So communication start from client to server. So second right answer is option C. Packet is going from client to server. Okay. So the next question, 11th question, if flag SYN is equal to 0 and ACK, this is acknowledgement is equal to 1 indicates option A open connection packet, option B open connection acknowledgement, option C FIN packet, option D acknowledgement packet. Okay, for this SYN then ACK, this is a field. If it is 1, it is 0 means it's called as request. This is client start the communication to the server. Again, if it is 1 and 1 means reply. That means the client send the data to the receiver can accept the data. It's okay, this is acknowledgement. This is 1 to 1 means reply. 0 and 1 means is acknowledgement. This is the data should be transmitted to the receiver. Okay, then the receiver is now send the acknowledgement to the sender. So 0 and 1. Last 0 means the data should be transmitted. It's completed the connection establishment. Both sender and receiver communicated. This is 0. So in our SYN is 0 and 1 means right answer is acknowledgement. So option D acknowledgement packet is the right answer for this question. Hope you all understand the concept clearly. So thank you for this opportunity. In coming videos, we will move the next concepts of TCP such as break, around time, sequence number, TCP retransmissions, everything we will discuss in coming videos. Thank you all.